Hello everyone, this video will explain the chain collider. If a chain collider were closed to form a polygon with the same appearance, it would seem no different from a polygon collider at first glance, as both are comprised of multiple vertices. However, regardless of whether the chain collider is closed or not, it has no area, no mass, and cannot be affected by gravity or collision forces, which is completely different from the characteristics of polygon collider. Therefore, chain colliders are usually used for static rigid bodies. They are utilized for creating irregular or complex terrain, such as the contours of mountains or multi-polyline paths. Their common properties have been explained in the video collider base, so I won't repeat them here. Additionally, in the box-to-D engine, for a collision to occur, at least one of the entities must have an area shape, which chain colliders do not possess. This means chain colliders can collide with other entities that have a solid shape, but will not collide with other entities that lack a solid form. In LayaAir IDE, to add a chain collider component to a 2D node, you need to click the Add Component button in the Inspector panel and select the chain collider under the Physics options. Chain colliders usually consist of a series of vertices connected by line segments, forming an open or closed chain. This structure does not fill the intermediate area. It merely defines the boundaries of an object. Chain colliders are composed of at least 2 points, but are typically 3 or more. It's essential to note that the segments of a chain collider should not cross over or intersect themselves, as such intersections can cause the physics engine difficulty in determining exact collision behaviors, and in clearly distinguishing which part should be above or below another. In LayaAir IDE, setting the datas for chain colliders is similar to polygon collider. By clicking the button on the right side of the datas, you can set the coordinates for each vertex through the pop-up panel. Like with polygon collider, in addition to accurately setting the data in the pop-up panel, you can also visually edit the vertices. First, visually edit the rough basic shape, and then make precise adjustments in the datas. When editing the shape of a collider, you can add vertices by holding CT or L and left-clicking on the edge of the collider shape. If you want to delete a vertex, you can do so by holding Alt and left-clicking on the collider's vertex. Let's demonstrate the operation. First, click the Edit Shape button to enter the shape editing mode for the collider. Then, you can change the position of a vertex by continuously holding the left mouse and dragging it. Add vertices by holding CT or L and clicking on an edge. And delete selected vertices by holding Alt and clicking on a vertex. Although chain colliders are typically used to create open, unenclosed shapes, such as the edges of roads or rivers, there are also scenarios requiring closure, like when all collision feedback needs to occur within a rectangular area or around a circular lake. Using the engine's closure feature to handle a complete chain collider, there's no need for developers to manually connect the start and end vertices. This not only improves efficiency and reduces the likelihood of errors, but also maintains the continuity and accuracy of the physical simulation. In LayaAir IDE, you can compare the effects of checking and unchecking the loop. Since chain colliders utilize single-side collision, meaning only the side facing the normal can produce a collision, the order of the vertices is crucial as it determines the collision direction. When the vertices of a chain collider are arranged counterclockwise, the normals face inward. Conversely, when vertices are arranged clockwise, the normals face outward. For example, when the vertices of a closed chain collider are arranged counterclockwise to form a closed area, an object colliding from the outside will penetrate into the area and then produce a collision inside, unable to penetrate out again. Conversely, when the vertices are arranged clockwise, inside the area, it can penetrate out, while from the outside, it cannot enter and will collide. If the chain collider is not closed, it still depends on whether the vertices are arranged counterclockwise or clockwise, unrelated to whether it is closed. For a chain collider that approximates a horizontal line, clockwise starts from the left to the right, and counterclockwise starts from the right to the left. If the direction from the starting vertex to the final vertex is from left to right, it belongs to the clockwise direction with normals facing upward. Collisions occur from top to bottom. Conversely, if the direction is from right to left, it's counterclockwise, with normals facing downward, and collisions will occur from bottom to top. With these examples, I believe you now understand the concept of single-side collision in chain colliders and its direct relationship with the order of vertices. The feature of reverse data precisely rearranges the vertices in reverse order. That is, it keeps the shape of the chain the same but reverses the order of vertices. This changes the direction of the normals, altering the direction of possible collisions. That covers the content on chain collider components. Thank you.